Okay guys, here's a quick video to explain how to get a precision CR10 setup guide or tuning guide. This is my first 3D printer. I got it 2 days ago. The first day I spent trying everything I could to level the bed properly to get a decent print, and nothing I tried worked, and eventually I looked at um, aligning and squaring the machine and fixing the bed and a whole lot of things, and I thought I'd share them with you because after I did that I got impeccable prints immediately. Now there's a couple of things. I do have a CNC background. I've designed and built CNC machines, CNC routers, so I'm new to the world of 3D printing. This is my first 3D printer, but the same tolerances that apply in the world of CNC routing or CNC milling apply to even more so to 3D printing, because here you're working with layers of 0.15 of a millimeter. So everything has to be just right in order to get perfect prints. So let me explain to you what I did, and hopefully this will help someone out there. So what happens is, when you get the printer, they're so popular that they're being put together very, very quickly and shipped out as fast as possible. So they're not paying much attention to precision of the machine when they ship it out. So that has to be tuned after the fact. Also, when you assemble the machine, you can't just assume that when you assemble the machine you're going to screw everything in and everything's going to be perfectly aligned. So you have to measure this. So let me go through all the things I did to fix the machine, and if you follow this list, I'm sure you will have a perfectly aligned and a machine capable of printing almost to perfection. So let's start with what I did. Okay, number one, the bed bow. So I'm sure a lot of you have realized that the bed isn't flat, or you think the glass isn't flat, or you go out to buy mirror tiles. I suggest you use a mirror tile from IKEA because it's absolutely flat, but if your bed underneath it isn't flat, there is still going to be distortion on the bed when you use the clips. So it's very, very important that you get the bed straight. So what I did is I first took off the aluminium heating plate, and I looked underneath, and on my machine, I'm sure your machine is different, but on mine had been assembled so quickly that underneath the plate there is this bracket that the plate that the rollers screw onto. So there's I don't know if you can see that, but here's your center beam, and then you got your rollers underneath that screw onto it. Now on mine, there's 6 screws, 3 on the left, 3 on the right. On mine, there were no washers on the one side underneath the screws, and the other side had washers. So now you are introducing a little bit of imbalance into the system already. You got different tensions from different sides. So what I did is I just took the screws out. I got my own washers, and I knew they were all exactly the same size and height. And then I put washers under all of the screws, and I put it back on again. Then I moved on to we'll do number 3 before number 2 actually. We're still on number 1, the bed bow. So what I did is I put it back on, and then you take a ruler. It's a metal ruler that's perfectly flat, and you put it on its side, and you look for a gap underneath the bed, and you place the ruler, this is the way I did it, from one corner to the opposite corner, like that, and you shine a light underneath it, and you can see I can guarantee you that your bed won't be flat. So you'll see that there's a gap underneath it, either like that, or you might actually see something like that, but probably the first one, because these screws over here have different tension. If one is putting more tension in one corner than the other, then you're going to have a distortion on the bed. So what I did is I put a little bit of tension. I made sure that I turned the screw the same amount. So two turns, two turns, two turns, two turns to get a bit of tension into the system. And then I used the ruler test. And while the ruler was on the bed, I adjusted the screws until I saw that the ruler was touching the bed perfectly and there was no gap underneath. So that's what you want to see. And you want to see it in that direction and in that direction and in that direction. Then you know your bed is flat. Alright, so that's very important to do. Then I moved on to actually squaring the machine. Now I can't assume that this machine is square as it comes out of the factory. And so this is what I do. So number 2, upright square. So this upright over here is screwed in. You screwed in yourself over there and over there. And what happens is that here's the screw, and you of course are using your screwdriver from underneath and you're screwing the upright. So these holes aren't exactly this perfect. There's a bit of slop in the holes. There's a bit of tolerance. So if you look at the holes, and this is the same for the brackets, if you look at the hole, there's a little bit of space on either side of the screw, and if you just happen to tighten this down, there's no guarantee that you're going to get this perfectly in the middle, and you're probably going to land on tightening a little bit more to one side or to the other. And the same with the brackets. So if you got your, just excuse my drawing, it's very crude, but there's your bracket, there are your holes, and the same thing happens on your bracket. So it's very possible when you put the machine together that you're going to have it one way or the other. Now, because we're working with very small tolerances, we're working in tolerances of, let's just say, 0.15 of a millimeter. If this play here is 0.2 of a millimeter, that can throw your whole machine out, just not putting this in properly and getting it square. So I loosened, I loosened, before I loosened the one side, I took a ruler, preferably a ruler that's got it shows half millimeters on it. So this is the ruler I used. You want a ruler, a metal ruler, and you can see here it's got half millimeter increments as well. So you want to use something like this that's flat for your bed, so you can see if there's a light gap underneath, if there's any bow in the bed, and also to measure the distances between the extrusions to make sure it's square. And you want to measure the distance from the very edge of this extrusion. If you can see that over there, the very edge of this extrusion to the very edge of this upright on that side, and then on this side. And you'll take your measurement. So let's just say this is 100. You want this distance also to be 100. Whatever it is, you want them to be the same. Now on mine, I was out over here by 0.75 of a millimeter, which is a lot. So I fixed that, got them exactly the same thing, distance apart. And then I did the exact same thing from this middle beam to there, and on the same thing on that side, middle beam to there, and let's say that was 50. You want that also to be 50. On my machine, mine was out by 0.83 of a millimeter, so I fixed that. Then the next thing you want to check, this is very, very important, is your gantry x-axis square. So over here you've got this beam that rides across, and this beam moves up for Z, and your print head moves left and right for X. And it's very, very important, vitally important, that this is parallel to your bed. So when this print head moves from here to here, and we've adjusted your bed to be flat, you want to have the exact same distance from there down to the bed as you have from there down to the bed. So the way you won't be able to measure this with a ruler. The way you measure and you fix it is with a dial indicator, if you've got a dial indicator. So you put your dial indicator, they normally come with a magnetic stand. You can't use it's on aluminium or one magnetized, but you try and strap it down onto with something heavy, or you position it where it's not going to move, and you put the block over here, and then you position your however your stand works. Here's your dial indicator, and you put the needle on top of the beam, if you can see that, and you get a measurement on the one side. So let's just say, so you put some tension on that needle, you zero out your dial indicator to 0, and then you take this same setup, you move it to this side, you put your dial indicator on this side, and then same thing. You see what measurement you get on this side. Now I was out by, or not whoever assembled this machine at the factory was out by 1/5 of a millimeter. So the way I fix that is on this beam over here, there's T-nuts that you loosen. There's 2 over there. There's 2 T-nuts and a bracket, and there's eccentric nuts for the wheels, and you basically get this into position. You tighten it semi-tight down until you get this to 0, or as close to 0 as you can, and then you slowly tighten this up, each screw a little bit at a time, till you get this as close to 0 as possible. The best I could get these two in parallel was 5/100 of a millimeter. Well, that was the best I could do on my machine. You might have better luck on your machine. It all depends on how precisely the hole's been drilled through the aluminium extrusion, and the play in your bracket and your wheels that ride on the gantry. If I've got layer heights of 0.15 of a millimeter, and you just draw it here, and here is the beam, and from left to right there's a slant like this, I'm exaggerating, of 0.25 of a millimeter, then when you're trying to put one layer on top of the other and the next one's coming down, you're going to land up with something like that. So that's vitally important that you fix that. Once you've done that, you do the paper test, which is you just make sure you got a bit of slip under each corner, and then you do your first print. You'll find that it's considerably better. This is just to give you an idea. This was after a day of trying to level the machine, the bed, before I did all of this. This is the best kind of print I could get. And using the exact same file after I did that, this is the print I got. So it's not perfect yet, because this is just the paper fit, but considerably better, right? Okay, then now you want to fine tune and get very, very, very good detail. Something like that. Okay, so what I did next is I went into Fusion 360. I drew a circle in Fusion of diameter 140 millimeters, and I extruded it up and made it 1 millimeter thick. Pulled this into Cura, and then I turned it into G-code, and then I printed this on the machine. And while it's printing, I watched it very carefully. So here it is over here. If you can see that. Okay. And while it's printing, you will see as it's going, so it's putting down 0.15 of a millimeter layers at a time, and you'll see very easily where your machine's out. So you'll see that, oh, there's a little rough patch over here. It's the bed's too high over there, and you'll just tweak that knob, tweak, just one little tweak, and then patiently watch again, and you'll see, oh, okay, now it's put the second layer on top of the first, and you'll see, oh, there's a little bit of a rough patch over there, or you can see the plastic's getting a little bit transparent over there compared to somewhere else. Then you just tweak that screw and that screw, teeny little bits at a time, till you get it perfect. You can rely on the feeling of your hands. The feeling of touch is very, very sensitive, so you'll feel any irregularities in the surface. And you can also rely on light. So you see this disc over here. As it's printing, you can look from a corner at an angle like this, from far away of the machine, shine a light, and the light will identify any irregularities on the surface. You'll see like a different shimmering pattern in one corner or another corner, and you'll know that there's something not quite right there. And then that's what you get. So this is what I landed up with. So this is the only thing I printed while the machine was going. You can see the marks from the tape underneath, the masking tape. And then this is perfect. You can't actually feel any difference on this at all. And you can use this to get your machine pretty darn close to perfect. And after that, you should be having perfect prints. Alright, so once your disc comes off the machine and you've tuned it, you want to make sure that your dimensional accuracy is correct. So if you recall, we made this 140 diameter by 1 mil thick. So you take your digital calipers, if you've got them, hopefully you do. So firstly we want to measure thickness. So we choose this spot to measure. We want to make sure that we miss the lip. We're just measuring the surface in the middle, and see if I can get that for you. You can see it's dead on 1 millimeter thick. Okay, so remember that is now many 0.15 layers on top of each other, and that's exactly 1 mil thick for the diameter, and that should be as close to 140 as possible. So let's try and open these nice and wide, and I will try and find the direct high spot across the circle. Just bear with me, it's not easy to do. Okay, there we go. I don't know if you can see that. 139.98, which is pretty much perfect. I mean, I don't think I can ask for better than that. That's pretty impressive. Alright, so yeah, once you've done that, you got those results, you can be guaranteed that your printing is going to be perfect every time, providing you use the right settings at Cura or whatever you're using in your slicer. All right. Well, I hope that helped someone, because that's what I did, and it worked like a dream for me. And let me know if it works for you as well. Thanks, and have a great day.